got to put patches on it. Yeah. Okay, guys, let's go. So today I'm going to talk to you guys about a small tool I wrote for DNS reconnaissance. So a bit about me. My day job is as a director of reverse engineering for a security vendor. In fact, we're sponsoring right next door. I work for Tenable. I'm one of the hosts in the Paul.com podcast. In addition to that, I'm also the host of the Paul.com Espanol podcast. So I kind of run both of those. I'm also one of the contributors to Metasploit. I'm one of the community developers. So if any of you have ever used any interpreter script or has ever used any post module, probably you have used some of my code at one time or another. Or if you've used any of the auxiliary modules, a couple of those I have written also. I have a blog, which is www.darkoperator.com, and you can find me on Twitter as Carlos_Perez. Disclaimer, and this was a request from work. This research and slideshow is my own and do not in any way are related or of knowledge of my current employer. All expressions and comments are my own also. Okay, now we have got the CYA out of the way. So what is Recon? Recon is the systematic and methodological approach that we take for gathering information about our targets. And I want to stress the part of systematic and methodical approach. Sorry, English is not my first language. So by this I mean that we do take our time to find information, and we make sure that the information we get is the right information that we want. And that we do take our time to analyze that information. And one of the reasons that I mentioned this is that I have seen many automated tools out there that many people write for reconnaissance, and there's this big bash script that runs a ton of tools, almost all of them, that can be found under pen test, enumeration, and backtrack. And then they gather tons and tons and tons and tons of text, and they do not know what to do with that text. Or in many cases, they do not know how to interpret that information. Or in many cases, as an example that I've seen, people like writing tools that go to whois, get the net ranges out of whois, and then scan all of those net ranges for all of the IP addresses that they found from a given domain. Well, what happens if that company actually uses a service, let's say from Akamai or from any other big hosting company or contribution distribution system? You're going to get their class 8/8 addresses, right? And you're going to be doing whois against whois, and then you're going to be getting those, and then you're going to be doing discovery against all of those ranges, and you're going to be losing time. You're not focusing. Your automation just bit you in the butt. So I've been seeing kind of a bit about that. So another thing that we try to gather is, what is the security posture of our target? Do they actually know their stuff? We can tell a lot just by enumerating the targets, just by looking at the services. How did they configure those services? What banners are we seeing? What countermeasures can we detect during the enumeration to actually know if they actually know their shit or not? Are they doing proper security? So one of the reasons that I wrote this tool is that I like DNS for many of its benefits. And benefits is that DNS today, everything in the enterprise relies on it. If we want to set up a VoIP system, it relies on DNS for the SRV records. If we want to do instant messaging, let's say Jabber, we require DNS and SRV records also for that one. If we want to do email, we require DNS because we got to know where are we sending our emails, and people need to know to who they need to send it back to us. And then for management, many management solutions nowadays also rely completely on DNS, because those days of us putting static IPs on our code and putting static IPs on everything, those who have administered large network know that that is painful. Many times IP changes, many times we restructure our networks, and just using DNS makes our life easier. And as an attacker, it also makes my life easier. It gives me one single place where I can get a lot of information. So another thing is that why I like DNS is that most organizations do not monitor their DNS servers. Many times I've been able to gather information. In fact, I've only seen the one that actually does it. And I'll talk about that one a bit later on, because we had a bit of a cat and mouse game with one of the enumeration techniques that I use in DNS Recon. Many times I can do zone transfer, I can try zone transfer against most of them and they won't see nothing. I can start just brute forcing the entire dictionary, the complete dictionary, going at it, thousands and thousands of lines, and nobody notices that their DNS error is giving out no NX records or no NX domain found or all of those errors. They're just missing them. It is in the event logs, it's in syslog, but nobody's actually looking at those. Nobody knows that they're being enumerated via DNS. Why? People just ignore that. In fact, those that actually do monitor tend to be the security team, and the security team, what they actually monitor for is the IDS and IPS alerts for zone transfer. That somebody's actually trying to do a zone transfer against their domain. That is the only thing I have found that most companies actually do monitor for. And that is because the IPS has a rule that they just click on a checkbox and enable it. And as I mentioned, it can give me information about the posture of security of that target. Caveats of DNS. DNS is UDP. So everything relies on location, location, location. The closest I am to the target, the better information I'm going to get. So many times, one of the things I try to do is I try to get a VPS service that is similar in the same area or network address range as my target or geolocation of my target. I try to, if they're here in the States, I try to get a VPS in the States. If they're in Russia, I try to get a VPS in Russia. In Russia, they're quite cheap and they're quite nice. And depending on where I want to actually gather my information, and many times probably I'll move my target, or probably I'll find an open DNS server close to that target and I'll use that one. As I mentioned, location, 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 because this is UDP. Another thing is that DNS tends to have a lot of fake entries. People do not like maintaining their DNSs. So many times we can find a lot of hosts that were actually there and they remove, and we can start getting names of those hosts that were actually there. We can also start seeing sales records. We can start seeing development records or testing records. And in fact, I have seen many places where I could start seeing them as they were doing troubleshooting, adding additional DNS records that gave me information about other hosts in the network because they were troubleshooting and adding entries into the DNS that they forgot to actually remove. So I wrote a tool called DnsRecon. It's included in Backtrack Linux. I have tested it on OS X, Linux, and Windows. It's written in Python. I took the time to make sure it works on Python 2.6, 2.7, and 3.2. Being the 3.2 one being the most painful one to actually make sure it was compatible, all three of those. Originally, the original DnsRecon tool, I wrote that about 2 years ago. It was written in Ruby. It was included in Backtrack 4. It wasn't so good. The Ruby libraries actually kind of stank back then for doing DNS stuff. And then what I did, I shift over to Ruby, to Python. And Dave's quite happy about it. So one of the things I also did was I wanted to make the data that I gathered quite useful. So I had 3 options of saving my data. I can save my data in an XML file format with all of the nice info, very well formatted, very well tagged. I can also provide a user a CSV file that they can use, they can open Excel, LibreOffice, and they can kind of parse the data as they want. And also I provide the data as a SQLite 3 database for those that like SQLite and doing their own queries. Quite useful when you're enumerating very large infrastructures or very large clients. Also, I included with the tool a Metasploit plugin for reporting the XML and CSV data into Metasploit. And also I included a parsing tool. Recently, a guy from Accubant found out about the parsing tool and he started emailing me how happy he was about it. Also, I found another person on the internet that after my presentation in DerbyCon also found about the parsing tool and started providing feedback and was quite happy about it also. So when I wrote the tools, many of my goals were provide most of the known DNS enumeration techniques in one single tool. Another thing is I wanted to give the user complete control of what they're doing. I hate tools that I cannot control. where the tool actually, I just give it a domain, let it run by, and I do not know what it's doing. I don't know if it's hitting the proper targets. I don't know if it is going out of scope, if it is gathering information that I'm not going to need. I want to know what it's doing. I want to control what it's doing. So I made it so that I can select specifically the different types of enumeration, and I can control each one of the different settings in the tool. So many times you'll find, let's say, a great tool like Fierce. I see that as a squad automatic weapon. Very good at just going out there and getting all of the information I can and just hitting a bunch of stuff very fast. In my case, mine is more like a precision weapon. I like going for specific pieces of information, and as I need more information, just keep gathering a bit more and more and more. Another one of my goals is that the output had to be very easy to parse, very easy to use. I see many people actually write tools that do very nice thing with end curses and do also nice ASCII art and other stuff in their output. But that output, when I need to parse it, I need to grep it, or I need to consume it, it's a pain in the ass to actually use it. It looks nice. It looks nice when I put it in Pastebin to talk in the forum and say that the tool is doing stuff. But when it comes to the time of actually using the data, it's quite difficult. So one of the things I stressed a lot was I had to make the data very useful for people. So the different types of enumeration the tool actually does is standard enumeration. What standard enumeration will actually do is it will check for wildcards. So I know if they're actually resolving to anything to one specific IP address. Also, I wanted to be able to enumerate if they're using DNSSEC. And also, I'll retrieve the name servers, star of authority, mail servers, A records, quad A records, TXT, SPF, and SRB records only with the standard enumeration. In addition to that, I added other options for doing zone transfer, reverse lookup of IP ranges, domain and host brute force, cache snooping, zone walking for DNSSEC zones, and also do a bit of Google lookup. Okay, so when we're going to standard enumeration, the first one is wildcard resolving. Why? Many times people do this to make it difficult for anybody that's brute forcing a network. It will always tell you, this is the IP address, this is the IP address. So when we're doing brute forcing, that's kind of painful, especially if we don't have any way to parse that information. Well, in DnsRecon, if you give it the -F option for filtering, it will detect the wildcard record, it will detect what is the IP address, and will just ignore that IP address and only show you the records that are unique. So that's why I'm doing the check for wildcard records. I'll check if they respond to DNSSEC. And then I'll also check what is known as the proof of non-existent record being used. In other words, are using NSEC or NSEC3. Believe it or not, a lot of companies very recently started going, oh, we're using DNSSEC, and we're happy about it. And I started checking each one of those. And many governmental agencies also. And they were using the old version of DNSSEC, NSEC. And I'll show you what are the problems when you actually do that and what are the repercussions. Also, as I mentioned, I also resolve star of authority, name servers, the standard records that you can actually get, TXT records, FPF records. Also, I can enumerate SRB records. Those are one of my favorites because it will actually provide me, this is the host, this is the service, it is TCP, UDP, or whatever protocol it's using, and it will actually tell me the port, and it will actually tell me what is the order that it should be connecting to that service. And SRB records are used for Jabber, it's used for link services from Microsoft, that is used by Active Directory, it's used by a lot of stuff. So that information is quite useful. Also, one of the data that I can gather if there's using DKIM, domain keys identifier for mail, also sender policy framework. If I start seeing this on a domain server, I'm already getting the idea. These people are actually taking security seriously. So I gotta be careful when I'm doing my phishing attempts. Why? They're actually checking the DNS entries and actually telling people which hosts are the ones that are supposed to be sending email out on their behalf. So when I'm doing my phishing attempt and I'm able to determine with what organizations they are interacting with, one of the first things I'm going to do is I'm going to check those organizations if they're actually implementing these types of controls. Because that means that their mail servers are actually going to check for this, if they actually implemented that for their own. So I know from which organization I can phish from or try to make myself look as I'm sending the emails from and from which I should not, just by looking at the types of controls that I'm seeing. So this is giving me an idea of the security posture of my target. SPF will actually tell me what machines can actually send email out of their networks. And many times it will include a very nice range, or it will give me a record that will point to another TXT record that will give me all of the ranges of all of their machines that actually can send email out of. And that will also provide me information where I can find open mail relays, which is quite nice information to find. SRB records, as mentioned, I really like those. It tells me the service, the transport, the port, and order of importance for the service. The type of software many times is also included in that information, or it could be deducted just by looking at the record. Also, for those records that are actually there, like stale records, or many times when they're not using split DNS and they're using one single DNS infrastructure, I'm not able to get A or quad A record for a host, I'll actually provide you an entry that says no_IP. Many times probably we'll start finding leaked internal DNS names to the outside world. And with this, I can actually identify many times when they're using, let's say, acme.com is their external infrastructure, and then corporate.acme.com is the internal one. And I can be able to kind of find this information just by looking at these records that actually failed, but do exist. They do have an entry, but the IP address could not be gotten from it. So when we start using DNS enumeration, typically for the standard enumeration, we just give it a -D and the domain name, or we can do -D domain name and -T for the type of enumeration, and we can give it standard. I can actually tell it to do also a zone transfer, and I can do that by just give it -A. It'll also perform a zone transfer. Even though if the zone transfer is successful against one DNS server, I'll also test the others. In addition to that, I will still enumerate the records, and I'm going to tell you why. I had one case when the admin was very, very smart, and he actually set up a dummy NS server that actually provided a zone transfer for me. And where he pointed all of those records that were in that zone transfer? FBI and NSA. So if I'm a pen tester and I'm not careful, I do not validate my targets, I was going to start hitting IP addresses for the FBI and the NSA. And that's bad. And many times what they'll do is they'll set up fake servers, they'll enable zone transfer, and they'll point you to, let's say, a group of servers that have Librea, tar pits, and other stuff in them configured to make your life live in hell. Because many times when you actually tell an admin that there's going to be a pen test executed next week, that's when they decide to get the the creative juices going, and they start actually implementing good security countermeasures because they want to make the life miserable for the pen testers. Never did it for years until management told them that there's a pen test going around, and they come up with ideas like this one, which I actually saw. So that's why I actually, in addition to the zone transfer, provide you the other information so you can actually correlate that information. In fact, I've been seeing that happen a bit more as many people are taking classes for defensive countermeasures. It's not my cell phone. I have it on.
All right, is it still okay?
Yeah.
It's your electromagnetic personality. Maybe it is. Yeah, maybe just put that,
Okay.
just move it away from your body a little, I guess.
Okay. Another one of the options that I offer is that -S. -S is that where when I look at the SPF records and all of a sudden those SPS records, I start seeing different ranges. I will perform a reverse lookup against all of those ranges. So automatically I'm gathering additional information about my target with the standard enumeration. So here we have an example. Here we have Cisco. I'm running just -D with, for Cisco. Here we can see that I can get their start of authority. I can see that they're not using DNSSEC. I can get their mail servers, and all of a sudden here I can see their SPF record. And as you can see here, I can see all of the different IP address ranges that I can actually get from them that they're already telling me this is my IP address range, and all of these machines are allowed to send email to the outside world. In addition to that, you can see that I can get their SRV records. I can see that they use SIP, so now I know that they're using actual VoIP in their environment. I know that I can see XMPP, so I know that they're using Jabber in their infrastructure. I can see another domain that they actually own, which is WebEx Connect. So I'm getting additional information of other domains that they're actually using. I can also see that they have a federation connection with AOL. So I know that when I see SIP Federation underscore TLS, I know that they're using Link, Microsoft Link server. So they're using Link services with that organization. So I know that, one, they're using Jabber, two, they're using Exchange and Microsoft solution. I know I know that they're using VoIP. I know they're using video conferencing by the H323CS and LS records there. I can see which are the hosts, which are the ports that I can connect to those services to. I'm getting kind of a bunch of information, but just by looking at this. Zone transfer. Well, everybody kind of knows zone transfer and how they work. And believe it or not, we're still finding this in engagements. And we're finding a lot of it. I'm still kind of baffled, why are we seeing this? But still out there. So the way DNS Recon works is, it will query for the chart of authority record, it will find it, it will query that server then for all of its NS records, and then it will go it will check if that NS server actually has port 53 open. If it doesn't have port 53 open, I will not attempt a zone transfer, so as to not trigger any IDS or IPS unless I really need to. If it does find it, it will perform the zone transfer. All records are returned are parsed and formatted in a way that we can actually use that information. So I will not dump that zone transfer completely at you and let you actually do the parsing and manipulation of that data and checking it and getting the IP addresses for the different domains that are provided. I will actually get the record and check each one. I'll also perform a quad A enumeration to make sure I get the proper IP addresses for that info. So as to make life easier for the attacker to be able to parse the data. I made it optional, it's not a default, because many times when we're going into organization and we're doing a pen test, we can actually see, I don't know here in the States, but I remember a lot in Latin America where I used to operate a lot. Many times when I go to visit the customer, they actually have their data center in the lobby under what we call under a glass wall. I could actually see all of their servers, and they were kind of proud of them. And many times they will actually take me on a tour to actually see the data center from the outside. And many times, just by looking, I could see if they have IPSs or not. Or many times when we were talking in the meetings and we were talking with sales and we were talking what are their projections and stuff and we were scoping the event, many times the admin will actually tell us if they're using IPSs or not. Or many times, as Martin mentioned in his presentation, we just go into LinkedIn and we start looking at information and we find out that, yeah, they're looking for a Cisco IPS expert, or they're looking for the one from Hewlett-Packard, or they're using any of the other brands of IPSs, IDSs out there. So I get an idea, so I can decide if I actually want to do a zone transfer or not, because that is the only thing that most people actually kind of monitor for. So as I mentioned, there was an example where I actually had a person create fake ones, so that's why when I do the zone transfer, I will actually provide you data on all of the other records. Server can be decoyed, also can start seeing stale data. That's why also when I do the zone transfer, I get all of those records. I also do additional checks for those, just to make sure that those hosts are actually alive and the data is not old data that might be useless. So this is the example of running zone transfer, DnsRecon -D-A, or I can give it a type AXFR, or if I want kind of chain different types of enumeration, I can actually do it. I can do -T for type, and I can do standard enumeration, AXFR. Reverse lookup. We all know this one also. we just get what are called pointed records, so we're getting everything for IPv6 and IPv4, quad 8 records for the different ranges. It's multi-threaded. And one of the things I can actually do is, as I'm getting the information from my target, I can give it the -W option for whois. I will perform a whois on each one of the different IP addresses I got back from the standard enumeration or from the reverse lookup on SPF. And I'll provide you back information on what is the name of the company and what is the range, so you can actually cite. I'll show you an example why that is important. DNS records, for doing it, I can do -R, and I could give a sitter, or I can give it a star IP dash NIP. I can also do reverse lookup against all of the SPF record ranges are there with the -S. And if I want to do whois, is a -W. And here's an example where I'm doing this against a range here. You can see it running. I'm providing the information, the names. Yes, I do have 3 ESX servers in my home lab. That is my home lab there. And here you can see an example where I'm doing the whois against Hewlett-Packard. And how many of you would actually like to do a reverse lookup on those ranges? If you look at those are /8. So if all of a sudden you start getting 2 /8s, that means that those are a bunch of records to actually start doing reverse lookup against. So when you do the -W for whois, you will get this message. I will let you select which one of those you want to do it. You can say, let's say if I want to do it against the first one and the last one, I can do 0,2, or I can just tell it all, and it will run against all of those. Also, I can see that one of those whois returned me the range, but it didn't tell me the company. In this case, this is a CDN that Hewlett-Packard uses this, so that one would be out of scope. So I would look up a bit more into that one, and I wouldn't kind of stray away from the targets that I'm supposed to do. I'm just using Hewlett-Packard as an example. Yes?
So could the program handle doing 16 million records or 32 million records?
Yes, I've done it. And made the mistake of trying to import that into Metasploit, and it blew up. And also try, I can do it, we can bring all of the information, the problem is then parsing it. You'll have a very big XML file, or a very big SQLite database, or a very big CSV file. Domain brute force, we just run against, we just give it a domain list, and it will start going one by one and creating information. But I did add the -F option for filtering wildcard records. So if the domain actually has wildcard enumeration enabled, you can actually kind of filter those, and it will bring you the proper targets that are really valid there. So it kind of bypasses that countermeasure that some domain admins have been using for years. Here's an example. I'm doing it against Google, and as you can see, I'm getting A records, CNAME records, quad 8 records. I actually provide you the type of record, the target, and the IP address. So I do a lot of, in addition to that I'm getting the record, I'm actually doing additional queries against it just to make sure I'm getting all of the proper IP addresses per target. Cache snooping, this is one of my favorite ones. It happens not that often, but I have found 1 or 2 organizations that actually allow me to do non-recursive queries against their environment. And I'm able to kind of query and know what they're actually looking at. So very recently, I started kind of including a snoop.txt file with DnsRecon. And what I started doing was I started including the exact domain targets for update services, for different softwares, for Symantec, for Skype, software for Microsoft, software for Red Hat, Ubuntu. So what this will allow me is that I can actually query their DNS server, and I know if they have in a recently amount of time queried that DNS record, or they have that DNS record cached. That means that I can actually tell if they use Skype. I do not know. I can know if they use Facebook, if they use LinkedIn. I can know if they're actually connecting to Yahoo Mail, Hotmail, and information like that, which proved quite useful. Not very often I can get it, but when I do, it's quite useful. Yes.
I was just going to ask
Yes. I have found it sometimes in the external. And that's what I kind of find it very useful, because when it comes to doing phishing attacks, that means I already know what their relationships with those companies are. So the first thing I do is I do a standard enumeration against that other company, so I know if they're using SPF, if they're using DKIM, or any of those controls for spamming. If they're not, that means I can use them for doing phishing attacks against my target. If I see that they're using those controls, and my target's also using those controls, I'm not going to waste time, because I know that I can register as many domains as I want, but when they query those MS records and other information, I know that it's not going to be valid. So I'm not going to try to kind of mimic that other company. And here we have an example where I know that they're using Google, and I'm getting all of the records that they're using for Google and connecting to. In fact, let me show you here. Development. Here's the file that I mentioned. As you can see, I have there some of the updates for Apple, iTunes. I have VMware, LinkedIn, Skype. I can see if they're using VirtualBox or not, Windows Update, if they're using WinZip, TeamViewer, FileZilla, Java, WinSCP, Gem, Panda Software. So you can get the idea how I can easily, if they made that mistake with their DNS server, I can know what they're actually running on the inside. Doesn't happen often, but it does. It's quite good data. NSEC zone walking. This is when I abuse that proof of non-existence record, or NSEC record. It is slow, but very accurate. So I'm not able to do an AXFR now if you're using NSEC, but if you're using the NSEC, I probably can get your full zone. It can also reveal internal records. It is a feature, a capability, so it is something that is doing what it's supposed to do. So I'm just abusing it. The way NSEC works is that I can query a record, I get the response for a record, but what happens if I misspell my record? It will tell me, no, I could not find this record in my zone, but this is the next record in my zone. Is this the one you're looking for? So it's actually telling me what is the next record in the zone. So I just start going at it until until I'm able to get from the name server, tell me all of the next records in your zone, one by one. And each time it tells me this is the next record, I take that record, I append a 1, I try to query it, it tells me an error, it doesn't give me the information back, then I'll append some garbage to it, do another query, and then I'll try other permutations of the domain name until it gives me back that what is the next record in the zone. In fact, there's a federal agency that, when I was writing the tool, actually detected that I was doing zone walks against them. And I got to give it to the admin. Every countermeasure that was in the book, he started implementing it for bypassing zone walks. I bypassed that countermeasure, he implemented the other one. I bypassed that one, he implemented the other one. And just 3 days before going to DerbyCon, he implemented a new one that I have never seen and was not documented anywhere. I was going nuts because it was one of the examples I was going to use at DerbyCon that later I removed. Then I had to work with one of the developers that is in front of line to actually find a way to bypass that one and add that one into our file. So I got to give it to that federal agency. I promise not to mention them. But they actually did their work. They were monitoring their DNS servers. But recently, not recently, in 2006, they came out with a new standard called NSEC 3. NSEC 3 now uses hashes, so I'm not able to get that information. Unless I have a very beefy computer that can actually compute all of those SHA-1 hashes and start kind of brute forcing that space. And it would just be easier to do brute force of a dictionary brute force to get those records, instead of trying to brute force SHA-1 for the different NSEC 3 records. And here we have an example of a zone walk against Comcast. Comcast uses DNSSEC. And I was able to get a lot of records. from Comcast. All of their users plus all of their external enterprise stuff plus all of their internal management network stuff that was also exposed. Yeah. Another technique that we are seeing out there that is happening is SRB record leakage. Here we have an example of Dell. How many of you know what underscore Kerberos underscore TCP record is? Yes. We are actually getting their Active Directory records there. So this is a good example of leakage. In addition to that, I can start seeing domain names. AUSDC2K8 Dell 01. So I think that's a 2008 server in Austin, in their headquarters, Austin, Texas. So, yep. So I'm getting information already by this. And as you can see, we have records 143, 163, so those are external ones. And then as we keep looking, I was able to find 51 records of those. Here you can see an HNDK pass, the LDAP one, MSDCS. And then I decided to kind of look at, start testing each one of those to see, since domain controllers tend to be also TNS servers, see if they by accident also expose one of those to the outside world. Found one that was actually doing it, and I did another SRB enumeration, and look at these IP addresses. They're not internet routable IP addresses. So I'm seeing that they're using a 10 dot network for the internal stuff. So I said, what would happen if I do a reverse lookup against that range? In addition, I got 700, previously I got 51 SRB records. Now when I tested this one, I found 705 SRB records. I found all of their domain controllers throughout the world, Japan, Europe, and other places. And it additionally gave me additional internal IP addresses range that I could actually enumerate. So when I did my test against that internal range that is a 10 dot, which is non-internet routable, look, start getting all of those. And I did report this a year back to them, and they said it was not important. So, tap it through. Let's say in the case of Martin and Johnny, if they're doing an assessment and they get this information, now they know the internal naming scheme, so they can actually say that I'm the technical person for this company. I can call the receptionist. I know the name typically of those machines. I can ask her, are you using machine so-and-so? Yes, I am. Oh, I cannot get to it. Let's do some testing. Show me the IP. Can you tell me when you run ipconfig/all what you have? Okay, let's do a ping to this other IP address of another machine we know. Oh, you're connecting to it. Crap, I'm not able to connect to it. Why am I not able to connect? Can you do me a favor? Can you add an account to that machine? And it's useful for social engineering and getting more information out of my target. And here we have another one from Comcast, where I have, when I did this homework against them, I'm getting 172.30 IPs. Those are, again, non-internet routable IP addresses. How many of you know what an ILO is? Yes. So that means that that's the management interface for an HP ProLiant server or HP ProLiant Blade chassis. That means if I'm able to connect to it, I can reboot the server. I can even make the server boot off a USB drive on my machine, and I can actually boot it up, use ComBoot, use whatever other tool to kind of get the data out of that machine. I can boot backtrack remotely on the target server if I'm able to touch that. So I already know that they use ILO for management. I already know that they're using HP hardware. So the information is useless if I cannot parse it. So with the tool, I include a parsing tool. And this is an example of the help file for the parsing tool. In the parsing tool, I can actually give it a file name. I can give it -l or list. It will provide me a list of all of the names that it found, so I can add that to my dictionary from where I'm doing other brute force attempts against other domains, I can kind of generate my own custom dictionary as time passes. Another thing I can actually do it is I can actually give it an IP range. I can tell it, just show me hosts that are in this specific IP range, because this is the ones I'm interested in. Another thing I can tell it is just give me this host in this IP range for this type. And I can tell it the type. It could be an A, quad A, NS, MX. In fact, I can give it a regular expression, so I can include several of those. In addition, I can do regular expressions against the names for the hosts. So I can put in normal Perl type regular expressions there, and I can actually query for anything that has the word, like in one case of one network that I scanned, HSRP. I already found all of the routers that they're actually using clustering on. Give me all of those that have 6500, and I can find all of the 6500 switches that they are exposed into that world. Thank you, Cisco. Name, I can actually give a unique host names there. Here's an example in the case of Comcast. In the case of Comcast, I got like several 100,000 records on that one. So I only wanted those that were in the range for the ILO interfaces. So I only gave it the 172.30 range. I gave it a /16, and it brought me all of the ILO interfaces that they're actually used for management. So that information is quite useful then, if I need to use it. So I'm able to parse very large data sets with it. So here we have an example of another internal records for other servers that Comcast sadly exposes out to the internet that they're leaking. Here's that example. This one are the 10.147 range. Another of the tools I provided was the ability to import this data into Metasploit, because if we're doing a penetration testing, those of us that use the Metasploit framework are very happy to get that information into it, so we can start exploiting machines. So what we do is you copy the DNSR_import.rb file, you copy it into MSF4 plugins folder in your home folder. To load it's quite simple. Load DNSR_import, and it will provide you with two commands. The two commands are DNSRecon_import_DNSRecon_CSV, import_DNSRecon_XML, and you're able to import the CSV file or XML file generated by the tool. The only option that has is a -F option, so I can specify the file on each one of those commands. And here you can see an example where I'm importing all of that data. And as you can see, it is also determining from the SRV data what type of service it is, and it's setting up the proper service. It's also checking what is the type of record, and it will set the proper port and type of service for that record. So I'm kind of doing that intelligent parsing already for you in the plugin. So when I click on services, I can actually see for the SRV records, I can see which ones were for Finger, HTTP, HTTPS, SIP internals, and you can see already the ports and the state and the type of protocol, if they're using TCP, UDP, TLS, or anything like that. So, any questions? No? If not, I thank you all for being here. I hope that you find the tool useful and information useful. I just wanted to share with all of you guys kind of my approach of how I do DNS reconnaissance. Thank you.